Hello everyone, I'm Paul and today we're solving problem 594, longest harmonious subsequence. This is easy and here I will show you my thought process and the solution, so keep watching. The description is short. We are given an array nums and we need to return the longest subsequence in which the difference between the maximum and minimum values is exactly 1. Now, in case you don't know, if we remove this and this, the remaining elements form a valid subsequence, and if we remove all of these, for example, these two elements are also a valid subsequence, and if we don't remove anything, this is also a valid subsequence. So we can get a subsequence by removing some or none of the elements in the array. And for example, here in the case we are given this array, the result is to remove this, this, and this. And the difference between the maximum and minimum elements here is exactly 1, which is what we need here. So the maximum element is 3, the minimum element is 2, the difference is 1. Here we have 1, 2, 3, 4, 5 elements in the subsequence, so we return 5. Now the question is, how can we solve this? Do we need to sort the array? Do we need to use 2 pointers? Should we use dynamic programming here? What can we do? And the key for this problem is observation. Once we get the intuition, this is really easy. Remember that any valid subsequence, any harmonious subsequence, has a difference between maximum and minimum values of exactly 1. So what this means is that every valid subsequence will have only 2 different elements. In this case, this is valid, and here we have only 2 elements, 3 and 2. And the same will happen for any valid subsequence. We will always have only 2 elements in any valid subsequence. And what this means is we can create a frequency map from this, and then we can iterate this frequency map, and for each key we check if we have key plus 1. So for example, if we are 2, we are checking if we have 3, and if we do, we sum the count of 2 and the count of 3, and we keep the maximum result for every key in the frequency map. Let's see how this works. First, we are building a frequency map, so we iterate this from left to right from index 0. So first we have a 1, and the count for 1 is 1. We have seen the 1 time up to this moment. Now we update I, we have a 3, so we add here 3 with a count of 1. Next is 2, so we add 2 with a count of 1. Here we have another 2, so now we have 2 2's in the frequency map. Now we have a 5, so we add 5 with a count of 1. Next is 2, so we add 1 here. Now we have 3 2's. Next is 3, so now we have 2 3's. Finally we have a 7, so we add 7 with a count of 1. Now for the second step, we'll iterate through these keys, and every time we are checking if we have the next key in the map. So initially the result is 0. We start here iterating key 1, and from here we are checking if we have the key plus 1, meaning we are checking if we have 2 in the map, and we have 2 here. So we take the sum of this and this, which is 4, and we keep the maximum among 4 and 0, so we replace this with 4. And what this means visually here is that we are taking a subsequence with this and this, this, this. So our subsequence right now is 1 2 2 2. Next key is 3, and now we are checking if we have key plus 1 in the map, meaning 4, and we don't have a 4 in the map. And as you can see up here, we don't have any 4 in the array. So we need to continue with the next key. Next is 2, and now we are checking if we have a 3 in the map, and we have a 3 here. So we take the sum of 2 and 3, which is 5, and we keep the maximum among 5 and 4. So we replace this with 5. And just to be clear, here we can see visually what's happening. We are taking the subsequence 3, 2, 2, 2, 3. This has a length of 5. That's why we can replace our result with 5. Next key is 5, and we are looking for 5 plus 1, meaning 6 in the map. We don't have a 6, so we continue. Finally, we have a 7, and we are looking for 8 in the map, and we don't have any 8 here, so we continue. And now we end this loop and return the result, which is 5 in this case. Time and space will be big O of n, because we are iterating this array and we are building this frequency map. So now let's go with the code, and hopefully you'll get the idea. First, n equals length of nums, and now we'll create our frequency map. So map equals default dictionary with a default value of 0 for every key. That's why we use the word int. And now for every value in nums, map at each value plus equal 1. And now we can get the result. So the result is initially 0. We will return this, and here in between we need to iterate the map. So for every key in the map, if key plus 1 is in the map, result equals the maximum among the result and map at key plus map at key plus 1. So this is it for the code. Now I will submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.